Hello friends, welcome to my channel. Let's have a look at the daily challenge problem 814, binary tree pruning. So in this video, we are going to share two formats of solution. So the first format is based on recursion, which is a short solution. So we are going to do what the problem requires us to do in this format. And in the second format, we're mainly focusing on the iterative solution. So our goal is to look into some finer details. So first, I'll read through the statement of the problem, and then we do some simple analysis and finally share the code. First, let's look at the statement. So given the root of a binary tree, return the same tree where every subtree not containing a 1 has been removed. So the second paragraph actually defines what's a subtree. So here are three examples. So we are going to look at example 1 and 2 into some details. So in example 1, so if the root is 1, so if we look at the right subtree of this root, so this right subtree contains a 1, so the root of the right subtree should be retained. So we have 1 and 0. And then if we look at the left subtree, so which is marked in orange, it contains only 0 values, so we should remove this one. So the right subtree contains 1, so we should retain it. So afterwards, so we have 1 has a right subtree 0, and then 0 has a right subtree 1. So this is example 1. So in example 2, so if we look at the left subtree of the root 1, so the left subtree contains all 0 values, so we should remove this left subtree. So if we look at the right subtree of this root 1, so the right subtree contains 1s, actually contains 2 1s, so we should retain the root of the right subtree, that is 1. So we have 1 and 1. Then if we look at the left subtree of this 1, so it's marked in orange, it contains only 0 values, so we should remove this left subtree. Well, the right subtree contains 1, and so we should maintain it. So afterwards, we have the root with a value 1, which has a right subtree with root value 1. Then it again has a right subtree with root value 1. This is example 1. So similarly, we can analyze example 3. So before we look at the code, let's look at the constraints. First, the number of nodes in the tree is in the range between 1 and 200. So 200 actually is not a very large number, so which defines the size of the problem. So node value is binary, in other words, either 0 or 1. So with that said, we are ready to look at the method. So our plan here is to present the two formats above. So first, we are going to look at the recursive solution, and secondly, we look at the iterative solution. So now let's move to the first format, that is the recursion solution. So in this format of solutions, so first we're going to look at the stop condition or edge case if not root. So we're going to do return. So we return null or none. So this is the one case. If the root is not null, so what we're going to do is we're going to check the left subtree. So if root left, so we are going to do pruning for the root left. So what we're going to do is a self-call, self-prune. So let's see, self-pruning, prune tree. So let's call self. So let's see, root left. So after we prune the left subtree, so we're going to set the root left to be the pruned one. So this is one case. So similarly, we do the same thing for the right subtree. So root and do the reset. So self prune root right. So notice that in each of the two if blocks, actually we did two things. First, we do the pruning of the subtrees, and then we do the reset of the root left or root right. So afterwards, so we need to check. So for example, if say not root left. So this root left is after reset, right? And similarly, not root right. So this root is also after reset, and so not root value. In other words, if the root value is 0, then in this case we're going to return null. All the other cases, the corresponding to the cases that we should retain the root of the tree. So we're going to return the root. So this is the full solution. So this solution actually is very straightforward or direct. What we did actually just the problem asked us to do. So let's do a special case check for this format. Yeah, it passes the special case, example 1, I guess, here. So now let's do a generic case check. Yeah, it passes all the generic cases. So this is the solution format 1. So now let's move to the second solution. So we can copy this function signature and put it here, and then we change this to be v1. Let's see. Now let's look at this second format. The second format is an iterative format, iterative solution. So here we are going to try to do the removal by hand or in action. So for this, we need to check if a subtree contains one value or not, right? So for this, I'm going to write a function. So this function is a hyper function. So to check if the whole subtree contains value 1. So this is a Boolean function, but for here for this Boolean function, I will write in a recursive format. So define contains 0, so contains 1, so contains 1. So I'm going to input a node representing a tree. So we're going to check if the tree represented by the root contains a 1 value or not. So if not root, so we should return false, right? So if root value equals 1, this is actually edge case, so or base case, so we should return true. So otherwise, if the root value is not 1, so we're going to check if its left child or right child contains 1 or not. So we're going to return contains 1 root left or contains 1 root right. In other words, if the left subtree or right subtree, either of them contains 1, then it means the whole tree contains 1. So that's the logic for the hyperfunction contains 1. So now let's do the actual work. So for this, I'm going to introduce a dummy node. So let's call it tree node. So let's see, tree node, yes. So I'm going to use a value 1. So I'm going to retain dummy node anyway. So then I can let the root to be the right child of the dummy. So also actually in practice we can also write left to equals root, but we just need to do proper return finally. So in this way, what we are going to do finally is going to return dummy right after we do the work. So this part will be in an iterative format. So first, I'm going to initialize a container. It's a stack. So I'm going to put a tuple in it, root at its parent, dummy, at the direction. So let me make some annotations. So here, it's a node, its parents, and the direction. The direction tells us so if the node is a left child or right child of its parents. For example, here the root is a right child of the dummy, right? So this is what we intended to do. As next, so we are going to do the traversal, and in between we are going to set or do the removal. So first, I'm going to get the node at the parent at the direction, right? So it's s pop. And then we're going to check if node value equals 1 or not. So if the node value equals 1, so we should retain this node because the tree represented by this node contains 1. So then we just need to check if node left, so we're going to append the corresponding information to the stack. So node left, so node, and the direction is L, right? And then we're going to check node right. So there we're going to append node right, node, and it's right. So this is the one case. So in the other case, it's corresponding to the node value equals to 0. So in this case, so first we are going to check if we need to retain this node or not. In other words, we want to check if its left subtree or right subtree contains 1. So if not contains 1, root node left, and not contains 1, node right. So in this case, this subtree represented by the node contains only 0 values. So in this case, we should do the tree removal. We need to remove the tree represented by the node. So we need to check this corresponding to the reset of the child. Let's check if the direction is right or left. So if direction equals right, so we're going to set parent right to be null. So if direction equals left, the other case, so we're going to set parent left to be null. So that's a big case, so which we need to do the removal. In the other case, it means the node has represent a tree which contains 1, so we should retain this node. So we just need to check if node left. So we're going to append. So node left, node, and left. So actually parallel to here, right? So let's tap it, right? So then s append node right, node, and right. So that's it actually. So afterwards, so we just need to return dummy right. So if here we set left equals root, so we are going to return dummy left. So with that said, I guess this is the second format of solutions. So let's do a special case check. Yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the cases. So let's check again. So it should be reasonably fast because of the problem size. So I guess with this second format finished, that's about it for this specific problem. So here we presented 2 formats of solutions. The first format is purely in recursive format. So it's a verbose translation of the problem requirement. In the second example, the format, so we mean to understand some finer details, and we do the tree removal by hand. So in this part, there are some hyperfunction which we used in which we use the recursion, but the actual work is done by an iterative format of solutions. So with that said, I guess that's about it for this video. Thank you very much.